Hi guys. Can you hear me and how's the sound quality?
Hello, all good?
Okay. Well, yeah. So on Friday, as you probably have seen, there was the problems. I mean, with the internet. So yeah, that was quite challenging, even to send something. I don't know. Maybe I really hope that that's not gonna repeat, but it is what it is, and sometimes it's really complicated to find out any ways to connect if you have only like one internet. Yeah. Yeah. Well, it is what it is. Anyways. So did you try, guys, that algorithm to be programmed? Give me a second. I will take a look. What was there? All right. So we took a look last time on those sorting algorithms, right? So
Yes.
yeah. And if I'm not mistaken, the last thing we finished with, the class with was an overlooking of that fancy description algorithm in a way of dance. Well, maybe you remember it was one of video materials. And I asked you guys to try to make it on your own, if I'm not mistaken, or we were going to make it together. You can remind me, guys.
I'm just checking. Just give me a second.
Okay. Because if you didn't try to make it, then let's start working that algorithm. And then let's go for an OP, so object-oriented programming part.
Is it insertion sort?
No, insertion is the same like we IT guys call it stone method. That was related to a quick sort.
Bubble sort?
Quick sort.
No, I don't have it.
Ay, ay,
Can't
ay.
find it.
Okay, so you don't have it. Right. So probably I will share my screen, and then we can start working on it then. So the first of all, once I will share the screen, I will show you material, which I have. Literally, those are two scans from one of the books, which just has results of each step of this algorithm. Okay, give me a second. I have to find it. Okay, yeah, found this out. All right, so I'm ready to share the screen. Okay, so we'll be working in my Windows system. Yeah, and here I have two pages. Like they were made. All this is written in Latin, but I suppose it doesn't really matter actually. So you have an array, and you gotta sort it. So the quicksort method assumes that you have two indexes, one from the left side, another from the right side, and you are working on them, trying to find out an element and exact which is gonna take the stable position in the sorted array. That happens when both of indexes they come up to the one value, which is an index. So So let's call those indexes like A, which will be the left, and B, which will be the right one. So the left one can, or the A index can be only increased going on the right, and B index can go only to the left. So we have to in place such rule for this method. Is it clear?
Yeah.
Yeah, okay. So what happens next? Next, we're gonna make another rule, the rule number 2. So once we work on the interval, the first index which is gonna be affected is index B. So index on the right side of the interval. Okay, and let's in place the third rule. Once we are swapping elements, so once we change elements in by their places, we are changing the index we're gonna influence. So previously influence index A, then now we influence index B. If we influenced previously index B, then now we influence index A. And let's in place the last rule. So we are making comparisons of elements of index A and B till the case when A and B indexes they become the same value. So do all of these rules clear for us? So are they clear for us?
Well, I think, yeah.
Okay, so let's keep them in mind and let's take a look on example in the book which shows this. So index A starts here, index B starts here. And we are comparison elements 3, 8, well, no changes, so being affected. Again, no changes, B is being affected. We're swapping values. So now we're affecting so A is being affected. Here nothing is being affected, so A is still affected. So 5, 3 swapping them, so now B should become affected, so it's been affected. And again, so we're not swapping elements, so B is being decreased. And we come up to the case when A and B, they're the same. So they equal the value to this element which has the value in its index called 3. Okay, well, that means so since A and B are the same, so this element which they correspond to took its original place into the array. So it has its fixed position. And what happens nextly? Nextly, on the left side, we have a region, and on the right side we have a region, and we have to work with those regions in the same manner as we did previously. So let's take the region on the left. So we have two values, and first affectable index for a region is going to be index B. So 2 and 1, we're affecting in so we're swapping elements. So now we affected index index A, and A is being increased, and both indexes are they're corresponding to the value 2. So this value 2 took its place in the sorted array, and now it has a region on the left, potential region on the left, and potential region on the right. So on the right, it has nothing till the not stable till stable elements because 3 they have stable position, so they have nothing in between. So on the right side there is nothing. On the left side there is one value. Well, that's gonna be for index A and for index B. So this one is gonna be on its stable position. Does it make a sense?
Yes.
Okay, so we finished with a region on the left for these three, so we take the region on the right. And the story is the same, so we're comparing values, and as you can see, we're not swapping them. So index B is being affected, and this 4 becomes on its stable position. And again, on left side we have no unstable symbols. On the right side we have unstable origin. So again, here we are swapping elements, so index A becomes affected. Again, we are swapping, so index B becomes affected. Uh, Now we are swapping, so index A becomes affected, and it's been affected till the case when both of the indexes points to this tenant, and it literally takes its stable position. And again, it has origin on the left, origin on the right. On the right, it only has one element, so there's nothing to do. So it got its stable position. On the left, it has origin, which literally starts at this value, which is index A, and ends here, which is index B. And we keep in mind, so first we influence index B, and here we swap an element. So now we're influencing index A. So A is being increased. Here we again swapping them, so B is being decreased. So we're swapping, so A is being increased, and we are corresponding to by both indexes to this value. Okay, so it again takes its position, and it has origin on the left, origin on the right. And literally procedure should be continued till the case when we have no unstable symbols in the array. Does it make a sense, guys?
It does make sense, yeah.
Okay. Do we have any ideas how to program this algorithm?
No?
No. So do we have something that works in the same manner but's being applied for different regions? Well, the method maybe, right? The method of changing index, which is going to be affected, and it works for every region. And once we reach to one certain value by both indexes, that value should be placed into a resulting array. Have one functionality which is going to be repeated. Well, we have to place it into a function. Is it so, guys? Would you agree?
Yes?
Okay. Okay. So yeah. So it's gonna be placed um into it's going to be placed into the function. All right. The other question, well, how we could make such function? And here maybe let's start working on things. And I will maybe open the file. Well, just a regular Python code, and we will start working on it. So what do we need to implement here? Maybe I will close all the rest unneeded things, like this ones. Okay, so what do we need here? Well, the primary thing, we have to have an array, which is gonna be sorted afterwards. Well, we can place some elements there. Well, if you like, we can follow things from the book actually. The only we don't have here the result in sorted array, unfortunately. I mean, just showed in the end. Or maybe I can take a look if we have. No, we don't have it. So maybe it will be a bit problematic to take a look on the results. Okay, then in this case, let's just work on this array. Uh, all has to be good in this case. And now let's create a function, and since we're making function on the same scope, then the array will be accessible into function. So um, so literally, well, and since we have only one array and we're mixing up elements inside, we won't be making any other arrays. So, anyways, we will be printing an array twice, just because we will be trying to show unsorted variant and sorted variant. All right. So we will be defining a function. Well, let's call it a def for a definition, and we will be having a quick sort. That's gonna be a name of the function. So nextly, what we'll be doing? Once the function will be done, we will be just running it somehow, or maybe with some arguments. Let's see. And afterwards, we have to have a sorted array in the end. That's how we will try on it. The thing is that we have to remember that sorting happens on the origin. So that means that we have to give indexes of elements. We will be starting or take a look on the origin. And well, we know that a minimal index is 0, and the maximal index. How can we get it? This? Who can tell me? How can we get the biggest index of the array? Is there anyone who remembers this? Which function do we need to use?
Yeah, max. A dot max.
A dot max. Okay, A dot max. Might be. Okay, what is the other option? What's about the len?
Oh yeah.
And since we get amount of elements, so we're decreasing that to have for one more less, and and we will give names of arguments of the function, and the first is gonna be a second is gonna be b, which is frankly saying, well, quite understandable thing. And here's afterwards, when we will be reaching to one particular element, we will be looking on the left side and on the right side of that. But as we understand and we can correspond to the book, when we go from this element on the left and on the right, we go from the element on the left till the very left, and from the element on the right to the very right, which is initial A for the region and initial B for the region. Does it make a sense?
Yeah.
Okay, so which means that we have to save them. So we can create something like A old is A, and B old is gonna be B, because we have to memorize them, because afterwards will be A and B. Another thing that we have to have terms for editing an index. So saying means that we have to have a turn. And if we remember, we have to we have to be dealing with A and B indexes, but primary, or let's call it initially, an index B is gonna be. So we will say that if turn is equal to a 0, then we are affecting E. If turn is gonna be 1, then we're affecting index B. And now we literally can make some calculus on all this. What is the reason when we make computations, and what is the condition for making any comparisons? Well, a condition is that both indexes, they're not same. I think you would agree, right?
Yeah.
Yes. So it means that we can make an if statement, which will just show that values are not the same. And since we need to run a calculation which is going to be periodical, then we can make a while loop that will be working on this on this condition. Or some of you could say that well, we wouldn't need an if. Well, and maybe we can just use a while condition. Um, so it's gonna be working till the case or during the case when A is less than B. Well, maybe we can do it that way. Okay, what is gonna be next? Maybe guys, you can tell something. What is gonna be next? How do you think? Maybe you have some ideas.
We need to start sorting from left to right.
No, we have to start comparison. So A and B, they're just indexes, and we have to compare values. Oh, the only array. Let's give some other name to the array. Something like this one. Otherwise, we'll have both A's, so we won't get access to the array. Otherwise, so let's compare. And the reason for a comparison that left element is greater than the right element. Because let's suppose we would like to sort an array in a scheduled form. So on the left we will have smallest values, on the right we'll have biggest values. So that means that if a index element is bigger than the right index element, then we get to swap them. So here let's make a swapping. Okay, so that's gonna be a swap. And what else should be done here for the swapping? Well, we have to remember once we swap elements, we have to change an index which is gonna be affected. So in reality, we have to change a term. So what we can do? We can do the following. So if turn, I will just write the full form. If you like to make it shorter, you can make it shorter. That's literally up to you guys. So if turn was 0, it becomes 1. Otherwise, it becomes 0. And after a comparison, we have to affect an index. So and right now we can make comparisons. What turn is equal to again? So if turn is equal to 0, then we're increasing index A. Otherwise, well, we have only one option, is decreasing index B. And actually, that's it. So I would say that's the full code. And as you can see, looks like it's pretty easy. Let's try to run it and let's see if we will get any. Let's hope that there are no mistakes. Okay. Yeah. So some of the symbols they can be missing sometimes. Uh-huh. Uh-huh. Okay. An interesting case, but was there anything changed here? Well, I would say not really. And anyways, we had 1 and we had 9. So this one, any value 9, 5, 3, 2, 7, 4, they're bigger than 1. So actually that's we have nothing changed. And this value 1, actually it took its value. Sorry, it took its position into sorted array. But the question is why the array is not being sorted. So what would you say, guys? What should we do next? What are your thoughts? So, any ideas?
Nope.
Nope. Okay, so again, let's take a look according to the book. What did we do? Here we literally made the process which is described on this page. So literally we found out a value of the element and we fixed that in the resultant array. So what is missing? The missing part is taking the left and taking a look on the right. Does it make a sense?
Yeah.
Okay, so how to do that? Well, we still have a function, and the function can always work on A and B indexes. So this while loop will be ended when A will not be less than B. So that means that A will be equal to a B value, and that will be kind of something like a central element, which is found to be um, to be at its position. So that means that we have to take origin on the left and origin on the right. So let's make it. Um, well, that means that we have to run a quick sorts. Well, both of them. Well, two of them. Well, this is gonna be for the left side. This is gonna be for the right side. So literally, um, here how we will go for the left side, and here is how we're gonna go for a right side. The only question here could be what a minus 1 and b plus 1 is over a region. So they're not inside because for example, in our case, this one is a fixed value. So region on the left going outside the region. So we have to use, or that's gonna be just a negative index, which will to work with this 9 value 9, which is not correctly. So, which means that before overlooking a region, we're sure that indexes fit the region. So, what it has to be? So, an index. We use this a old, which was original a, and that belonged to a region. But such values as a minus 1, b plus 1, they're not guaranteed to be inside the region. So that's why we have to use such we have to use such checks if it's really so. Yeah, something like this. And now, since we have a repeated repeated code, we can try to launch our codes and to find out if it's good and if all this has been correct. So, what do we have? What do we have here? Okay, we have a quick sort. Um, a previous line repeated. Okay, so we get to the maximal recursion amount. By the way, this recursion amount is not big actually. The main problematic is that the main problematic is that even if a old and a minus one and b plus one and b old are same values and they correspond to the same value, the while loop is not gonna be working. But in the same time, our quick sorting on the left region is still working. By the way, this amount of repeated elements, is pretty small for programming languages. So you just have to know it. So which means that we have to introduce here a new statement that will be working for while and this quick sorts only when originally A is in B. I hope you got the point. Did you? Oh, wait a bit. This has to be on its place. Yeah. So now these quick sorts they won't be executed when while is not working because while condition is being used even for the if statement. And now if we will try to run the code, let's see what we will get, guys. So we got sorted array. And that's actually the way how you can make the array sorted using a quick sort. So is this code understandable for you guys?
Kinda, yeah.
Kind of. Okay. Okay. All right. Then I suppose I will then send you this. I will then send you this file. I will share a link in the chat so you would be able to take it and maybe to work on it. Hmm. Okay, that's kind of strange. Ah, okay. Well. If the website is been confusing you, so you can even change the domain for a files FM. No big difference. So which one you're using? Okay, so are we good with this one, guys? Because I have heard answer from only one of you. Others say. Okay, okay, okay. All right. Well, the code itself is not very complicated. The only, you have to try them. You have to try to write codes. Okay, so what could be the next thing besides this? Well, at least we can try to have a first steps um, in object-oriented programming, I suppose. Um, and let me download materials so we can work on it. Okay, so material is openable. I will open the Apple downloads. Okay, and here we have it. An OOP. I suppose you already had maybe some theoretical course, maybe about OOP, it's really easy to imagine what does the object-oriented programming mean. Um, um, maybe you remember such things. Well, it's not related to the course itself, but I suppose that maybe in middle school or somewhere around that you maybe classifying something. For example, I suppose everyone had some. I mean, biology. Did you have biology classes, guys?
At school, yeah.
Yeah, for sure. Because actually it's a basic class. So remember that there was something like classifications of animals. Do you remember this thing?
Say again?
Classifications of animals.
Like reptiles, mammals.
Yeah, exactly. And actually, that was made in the way of the scheme with the kind, if you remember. Um, all right, so let me find this out. Because it's oh, okay. I found out a very cool image. Okay. Let's take this image as example, right? Okay. I suppose we remember such things, and actually, it really shows us the basics of an OP. I know in a fancy way, but anyways, so you see, every class of animals they have something characteristical, right? For example, warm-blooded. Well, we understand that this means that the animal has the warm blood, right? And in the same time, such group is being split in subgroups. Like this mammals, birds, fish, and others, and they're cold-blooded, right? And they're reptiles, amphibians, and others. And even each of these groups, it can be split in some smaller groups. I suppose we get this, right?
Yeah, yeah.
And for example, if we will take, for example, a fish, well, a fish has some parameters of the fish, plus it has parameters of the group which it is located inside, so it's a warm-blooded, and in the same time, it has parameters of um, vertebrates. So literally, a same principle is being used in the OOP. So we split something in groups, and elements of the group has all parameters of the group. That's the main principle of the OOP, just in few sentences, how to say. But let's take at all these things, maybe more practical. Let's maybe take a look how all this works in the syntaxes of the Python, and let's see how those classes can be created and how can we make some parameters. So the full let's think of how libraries are organized. So maybe you remember sometimes we use import, sometimes we specify specific class or specific function from the library, right? Is it so? For example, regex, so we used randomizer. Do you remember that, guys?
Yeah.
Yes. So literally each of those libraries we're using is being written in the form of a big class, where subclasses are those functions we can import separately. So we have to remember this. For example, if we import a class, sorry, the library, it has its own name. Well, we can get access to subvariables and functions written inside that, as well as subclasses, using the following construction: the name of the library point, and then we specify the thing which uh, could be defined into inside that class. Okay, maybe at this point it looks probably complicated, but we have to know that, for example, if we want to add and use something separately, like just one small maybe function or a subclass from the class, that means that we are specifying the library or the biggest of the group of the classes, and then we import from that one particular class. That could be a function, like in this case. Okay, so what should we know about programmatical classes? Well, programmatical classes, and by the way, now we're not gonna take a look how they have been implemented, because implementation is kind of complicated for them. But we will try to get their structure and how can we use them. So the class should be started with maybe some libraries import, and then we can create the scope of the class. So we need to write class, which is the keyword. Then we write the name of the class. Then we start the class block. And then what we can do? We can specify variables, or we can specify even functions. Um, for functions, it's really mandatory to create the first argument, which is gonna be reference for an item, which is gonna be created by a class. So literally the self, which is we write in here, is not gonna be used directly, but it only for entire implementation. So even if you're not planning to have any of the arguments, the argument itself anyway should be there. So, and once we try to create a class instance variable, we need to implement this inside the class in the following way. So self, which will be the reference for the object, point, name. So literally we will be working on a sub-variable name, and we will be saving into that the name value. Well, this name comes from this argument, and this name has nothing common with the argument, because before the name we have self and then point. So this name is the part of object itself. Does it make a sense?
A little, yeah.
Yeah, and when we will be creating instance based on the class, we will be making it in a such way. So we will be having variable equal and constructor of the class. And once we made variable p, well as by the scheme of the code of the person, then we can get access to all entires of the class, and you can run through the variable every function which was specified here. So so you have to know that we can have a couple of classes based on option of the class. Well, it's something the same as you would cook five soups by one recipe. So you can call this class code as the recipe, and you can call each instance which you made by the recipes, for example, a meal based on the recipe. That makes sense?
Yeah.
Okay. So let's go further. Okay, about the self I already described you. Well, about that self is not placed in functions. I suppose that's understandable. What will be the next? Okay, so as you have seen, we create object by using object of the class by using the class name, and we have to use brackets, because actually on the theoretical basis every class actually is a modified function, but not every modified function is the class. So that means that we create a result of the class as we would run a function without or maybe with arguments. So by default, when we don't give an option to the user or to the developer, we're not making such called constructors, which are functions which are going to be created once we create instance of the class, or if you like to call it maybe a bit different, than object of the class. Well, in this code we don't have it because the name of the constructor should be the same as the name of the class. So since we don't have the function person, so we don't have such constructor. So okay, maybe I will have the constructor itself. Okay, so here I have a constructor itself. And well, the thing which I mentioned you previously, that the constructor name has the same name of the class. That's actually kind of mandatory thing, but in the third version of the Python, and actually the programming language itself is being kind of um, uh, made in a way that the name of constructor will be just afterwards probably just replaced by the name of the class. So we use for the constructor name init. Well, there are two underlines on the left and on the right. which literally is the same as the function of the class person. And here again, we need to have a reference for the instance, and then we can list a couple of elements. Okay, so here for example, we have the case when we give some n value for within the constructor, but here we have two other components which will become a specific value. Well, like we see right now, so it's just an unknown. Okay. Well, what else would be an interesting here? Well, an interesting thing is that classes or class objects, if you like, you can call it them that way, can be used in the same manner as regular variables can be used in most of the cases. So that means that literally um, we can involve class instances into the array, for example. The same as we would do that for, well, maybe integers. Okay, well, what do we have here? So we have here people. We have here Bill, which is the person of the Bill. So we add Bill to the people. Then we create a person clear. Okay, and we add a declare to the people array. Afterwards, when we do this, we surely can be using both Bill and Clear for any other modifications, but those modifications they're corresponding to the memory in the computer, where a people elements are corresponding right now. So yeah, so literally now you have like a two references that would work with the same memory. I hope that makes sense. Okay, maybe we can just list this one, just pause it, because actually all this is, well, well, understandable things, I suppose. Yeah. Okay, what could be the summary? The summary in all this? Well, we can just use classes. They have a very specific implementation and maybe a bit tricky. Maybe we can take a look on some other examples for an OOP, and that's gonna be more for parameters which will be shared among sub elements. Okay. Well, I suppose this could be already, well, plus minus understandable. Yeah, let me maybe make it that way. So who can decide what do we have here, and which functions do we have here, and what this code does? So what would you say? It's very simple. We have even an output, and we have detailed shown which output corresponds to which code. Yeah, so it's like a list, and we declare the scopes. Yes, that's 100% correctly. All right, let's go further. Okay, so literally we have the class of a human. Well, as we understand, and by the way, it's the same. Like maybe you remember, Socrates. Maybe you remember such philosopher. What he became famous with, well, with a lot of things, but he had the saying that if every human is the mortal and Socrates is the human, so the Socrates is mortal as well. Do we understand this logical chain? I think yes, we understand. So literally here we have same things. So what do we have here? We have here the human, which is gonna be a base class from which parameters will be added to every of the sub elements or the elements of that humans class, where each of the elements, well, they have parameters of the human, plus they have their own parameters. I suppose this would be understandable. So in a way saying, well, both male and female, they inherit parameters of the human, so they overtake them. How can this be written in? So here we have the codes. So you see, and you can try them. We have the human, which has a parameter of a gender, age, and we can add, if you like, something in addition, like two eyes, two legs, two arms, and so on, and one nose, let's suppose. Okay, and it has a function of speak. So literally every human, if it's not done specifically, somehow different, then it's possible to speak. And we have a man which inherits from the human. That's why we have the human in written in the brackets. So in the brackets we have literally an inherited class. And nextly we have a constructor even for a man. But inside constructor of a man, what do we see? Well, we see init itself. We see a self in arguments right here, which is correctly. And here we have a super.init. Well, what is the super actually? For each class, when you run a super, it means that we try. The main word is try to get to an item or a function. If we write function of the super, that's been placed on the one level upper class in the hierarchy. So if our man inherits everything from the human, then super corresponds to the human. And it would be very easy to get this. So you cannot initialize, for example, a man or woman without parameters of the human. So if you don't have a human, so you cannot make that human to a man or woman. Well, programmatically saying, as we understand. Yeah. And here we are creating a man, and if you can see, we don't specify um, any we don't specify the inheritance here because we have to mention inheritance only at a definition. That's it. And as you can see here, we have an output of this code. So once super init refers to this human init, and it has the gender as unknown, which is a 0, so they've been set up. And guys, even if you have this super executor and you have self into a function which you are running by the super, so it still corresponds to the to the instance of your class. I hope that makes sense. So if you have the class based on, or if you have an instance based on the class main, so this self here, and if they would be here, they would be referring to this variable mn. Okay, well, this one I suppose very understandable. Well, here we just fill in a variable or the argument of the function. So we're specifying, for example, gender specific, and literally we override a default value of the argument, which is written right after its definition. Okay, so here we have a modification of it. So we have the hair color, and we have yeah, and we have self point hair color. So that means that man class will have more for will have more for a parameter. Okay, let's go further. Inheritance assumes that we can use all parameters and functions of objects which are studied upper in the hierarchy. Um, what do we need to guarantee to access them? So it could be so the case could be that well, if definitions are different, then we can just mention well, let's say whatever mention of the, let's suppose, function. Because if in one case we have one parameter list, then another case we could have a different parameter list. Not parameter, but argument list. If it happens it is on the slide, then what can we say about this? Well, we have the same name, we have same arguments, which means the only closest to the original object function will be launched. Okay, maybe we can just pause this one. Uh-huh. Okay. Well, there's specific cases when we don't need when we run a function a parameter's name. Especially that's possible when we have a chain of arguments, and we write parameters of the function right in the same order. Then this naming is not really needed. For example, here we have this constructor that has name, age, nationality. And we run the man class instance creation, which assumes these three parameters. And you see, we write them in the same order as they were defined. If only that wouldn't be so, then we would need to specify which uh, which value corresponds to which argument. Well, I don't know. All this looks quite easy. So I have a small class task for you guys. So here you have okay, we have like 20 minutes left. So you know how things can be implemented for the class. At least you can try. And here we have a classical class task where you can take a look and you can specify parameters for fruits, and you can make them in the way of class. And let's see how you will make it. Here you have a small so-called list of actions you would need to do. Well, since there are no questions, at least I didn't hear them. Maybe I can check the chat. Yeah, let's give it a try. Well, yeah, that's exactly what I wanted to say, because there are no questions, so why wouldn't you try them? Is the task understandable for you guys? Mm-hmm. Okay. So the only thing you need to try these codes. Well, yeah, you have an example. So I suppose it shouldn't be an issue for this. It just shouldn't be. Okay, so please try all this, and once you will get any results, please send them in the chat, or maybe through Files FM. You can send your codes. So a bit more than half of the time has been passed. Um, so how is it going? Is all good with this?
We're getting there.
Okay, so just try to make all this fully, because you know that this is the classical example actually. Okay, well, let's some 5 minutes more, and then we will try at least to start making that task. Well, we will just overlook maybe what you have. You can just after some 5 minutes send what you got at this point, and then try to make at least some beginning subtask of that class task. Okay. So, how's the progress?
Can you give us a few minutes?
Okay, yeah, okay. If few minutes are needed, then yeah, sure. Okay. So let's see what you send in the chat. Uh-huh. Okay, correctly. Okay. Banana fruit, orange fruit, print banana name, print. Um, all right, all right. Well, at least this one is so. Mm-hmm. Okay, so Mindaugas, and where you got the error? Is it in this code or in some other? Ah, fruit no takes no arguments. Um, Wait a bit. So I will copy your code and I will try to use it in my file. Surely I cannot copy those spaces as you understand. I will just use them. I will just make them. Yeah. So here we have them. Well, let's see how it works. Let's see if we will get any problems. Banana equal fruit. Fruit takes no arguments. Um, yeah, fruit takes no arguments. Self. Okay, self is there. Mm-hmm. And it's about the very first one. Int. Well, it got to be in it. So you created int, well, underline int, underline function. So you don't have constructor. Otherwise, you see that would be working. And moreover, since you have this speak, you can run a speak function. Let's suppose from the orange. So you see, orange speaks you, and here we'll get the text spoken by the orange. Well, let's see how that will be looking. Yeah, so you see, this is old orange. So again, here you had to have init instead of anything else. C++. Well, okay, yeah, int, yeah, C++. Okay, makes sense. Okay, let's add with this. Um, all right. The previous class was the C++. Okay, makes sense. Yeah. Absolute attribute error fruits object has no attribute. Let's see what we have there. But I suppose you copied not the food, but let me take a look. Let me take a look. Next, you have this one. Fruit is correctly. Uh-huh. Okay, you have super in it. Yes, that's cool. Next, we have fruity. We are printing something, and that and yeah. So let's have these things. Let's see what we will get here. Print apple color color. Yeah, you use the color with you only for the arguments, but you take the color with you, and you take its value and you write that in the color without you. So literally, this color without you is front of your fruit. So if we will change this color with you with the color without you, then everything should be great. So you see, it's fine. Yeah, so you can see the small things, they can be mixed up, but the same happens in every programming language actually. We get that separate access to arguments, and we have separated access to sub variables. Yeah. All right. Maybe it's a time for Q&As. Do we have any questions before we will finish? Yeah, well, that's understandable. The only you have to keep in mind that we have such form of classes that then we have like 1 week, then we get another few weeks, then we will get someone, right? And this makes, I suppose, a complexity for you. So it's like we're working some period, then we're not working, then we're again not working, and so on. Okay, and tomorrow again, like on the last week, so we will have 4 classes starting from the morning from 9:40. Yeah, and tomorrow they will of practicals, tasks, and we will be overlooking solutions. So welcome tomorrow for the classes. Alright guys, so if there are no questions, then I would like to say thank you for attending these classes, for visiting the session, and then see you tomorrow working on practicals. Alright guys, so have a nice evening and see you tomorrow. Bye bye.